Hi, boys and girls. So today you learned about Newton's third law, and the best way to show you about that a little bit is with the Newton's cradle. Talked about it in the last video, and I found a video of it, so we're going to watch it, and I'm going to stop periodically and let you make some predictions about what you think will happen. For some of you who've seen us do this at school, you just have to it'll be a good review for you. But I know most of the classes, I don't believe we've done this. All right, let's go. There's some super annoying music at the beginning. Oh, wait, let's go back to it. So I might flip through the music. Or maybe I'll just let you watch the whole thing. But there's way too much introduction. There's the giant cradle. It's very powerful. It's the Newton's cradle that will get you. Whose strings will be tangled. Okay. Now we're at the point where I'll stop a second. And remember that Newton's third law is that every action has an equal reaction and an opposite reaction. So when you have all those 5 balls in the Newton's cradle and you just lift one of them back, what will happen to the other side? If it's equal, what's the thing that's equal to 1, right? And opposite. So let's see if you're predicting. If it's an equal reaction, how many balls will it be? And if it's opposite, which way will that one ball go? And now let's take a peek and see what happens. Did you predict correctly that one ball would go in the opposite direction? Now there's one more thing to talk about in this is energy transfer. Now, when we studied heat transfer, you learned about the law of conservation of energy, that you cannot create energy and you can't destroy energy. Energy can just get transferred throughout the universe. So when you are looking at a Newton's cradle, you're seeing a specific kind of energy. When you pull the ball back and hold it there, that's called potential energy. That's energy that's stored up. Just by pulling the ball back, you have now stored up energy in it so that when you release it, it's going to be able to transfer that energy that you stored up by pulling it back and transfer it into the other balls, right? So when you lift up one ball and let it go, as you were doing here, let's just do this. The kind of energy that the potential energy gets transferred into is called kinetic energy. Kinetic energy is the energy of motion. So when you pull the ball back, it's full of potential energy, kind of like someone would say about you that you're just full of potential and you can do anything you want with your life. Well, this little ball has so much energy in it, it has the potential to make the other balls start clacking. All right. Watch. Energy is transferred from marble to marble to marble so fast and then sent right back. The energy is not being destroyed, just transferring. Now keep in mind that there's friction in the air. Let me hold this a second. There's friction in the air that will eventually slow it down because remember, if you did this in space, it would go on for eternity until another force is applied. But in our atmosphere, the other forces that are applied begin to slow it down. So it'll go on for a good long while. Now notice that the girl in the video, or the boy, I'm not sure, has 2 of the balls. So if the reaction is 1 equal and 2 opposite, what will happen on the other side when she lets them go? Think about what happened when it was 1 ball, if it was equal and opposite. And now if it's 2 balls and it's equal and opposite, what will happen there? Do you have a prediction in your head? Let's see if you're right. Were you right? I bet you were. I know you were right. You figured it out. And even if you weren't, now you know. Look at all that beautiful clacking. All right, now look, she's going to do 3 balls. Now let your mind wrap around this one. Since she has 3 balls and we know the reaction has to be equal, there's only 2 balls on the other side. So what could possibly happen that would make this true if Newton's law says equal and opposite? Well, opposite would mean to go the other way, but equal, it has to be 3 balls and there are only 2 over there. Can you visualize what could possibly happen? All right, let's see if you got it. And if not, that's all right. You'll see in just a second. It's pretty cool though. All right, you ready? Let's do it. Look, it's still equal 3, 3, 3, 3, 3, 3, 3, 3, and opposite 3, 3, 3, 3, 3. Pretty cool. All right, now this time, wait. They're holding it out and sending both balls in. So now, if both balls are coming in, it'll be an equal reaction, right? Because 1 and 1. And then what will be the opposite? That's my prediction. I bet you predicted the same thing. If you didn't, let's just watch and see what happens. You can see the energy being transferred through the middle balls. The wires are all kind of moving around. There's so much energy going in between those and back out again. In, out, in, out, in, out, back and forth, back and forth. All right, so now, same idea, but with 2 balls going in. This one I think is easier to predict since you already saw what happened with just 1. But let's see. Woo! And notice the ball in the middle, it's not moving very much. I'm thinking that the reason it's not moving very much is because the forces are almost balanced with the 2 equally massive balls coming in at them, but not perfectly balanced, which is making it jiggle just a little bit. That would be my prediction on that. Because remember, if the forces are equally balanced, no movement will happen. And when I'm looking at this, I see just a tiny jiggle. So it's almost equal, but not quite. Maybe it's because of friction in the air that's messing it up and holding one ball or the 2 balls back in different rates. Maybe the air's more dense on one side than the other. I really don't know why. However, I do know that since it's moving a little, the forces can't be perfectly balanced. All right, what are they? Oh, wait, what will happen now? 3 on one side, 2 on the other. Okay, wait a minute. Equal and opposite. So it would have to be kind of like the other one, right? If it's equal and opposite, that when the 3 hit, then for the equal reaction, the one in the middle will have to go with the 2, right? So the one in the middle will be the one that goes back and forth to make sure that it's equal each time, and then opposite. So I think that middle one's going to be winging back and forth. Let's see if I'm right. You think I'm right? Okay. Oh, look! Oh, wait, let's, what's going to happen to that one? Okay, I don't want you to lose your prediction ability. All right, so now real quick, what were they doing? Okay, so 3 on one side, 1 on the other, but it's got to be equal and opposite. So 3 balls will hit, right? And that means that 3 balls have to go the other way too. I can't visualize what's going to happen on this one. I wonder if you can visualize it better. All right, let's see. Oh, look! The one on the end, the equal one on the other side is the one that kind of stays put and everything else kind of claps. I've never tried this before. That is so cool. All right, now what are they going to do? Hold up. Oh! All right, so now 2 on one side, 1 on the other, 2 in the middle. So this is getting so much harder. What will happen? The 2 will come in and hit, right? These 2 over here will come in and hit. And then make those 2 go out. All right, let's see. Oh, it switches. That one is so cool. My mind is kind of blown right now. Like I'm not thinking through what happened. Ooh, they're taking one out. Oh, that's cool. It's still equal and opposite, right? One ball on either side, then the middle balls go in. This gives me so many new ideas to try at school. Sounds cute too. Okay, what are they doing this time? Same one as at the beginning? Oh. We got some beats going. Sounds like a snare drum in a band. All right, and then now. Oh, no! That one is so cool! All right, we'll stop right there. Newton's third law: for every action, there's an equal and opposite reaction. Yay! So cool! Yay! And let's